Welcome to the Deep Dive, where we take your source material and distill it into the most crucial insights, giving you a powerful shortcut to being well-informed. Today, we're diving into a critical topic that impacts anyone working near or involved with powerful machinery: arc welding safety. We've got a comprehensive document here, EAP.19 Arc Welding Safety, which lays out the significant hazards and, importantly, the vital steps to mitigate them. Our mission today is to unpack these details for you, highlighting not just the obvious dangers, but maybe some surprising, often overlooked risks and practical prevention methods, so you can walk away with a crystal clear understanding of what it truly means to work safely in a welding environment.
Absolutely. And what's fascinating here, I think, is how broad the responsibility for safety actually is. It really extends well beyond the individual welder. It includes everyone involved, even, say, a visual or welding inspector. So this deep dive, it should illuminate the 4 key areas of risk that demand constant vigilance. It's about ensuring not just your safety, but the safety of those around you, too.
Definitely. Let's dig in. So when we talk welding safety, I guess the first thing that probably zaps into your mind is electric shock. And it's not just a jolt, right? It can cause serious injury or even be fatal, but it sounds like it's far more complex and maybe often more insidious than just that simple immediate current, isn't it?
You're absolutely right, yeah. Our source highlights 2 critical categories of electrical risk. The first is primary voltage shock. This is often at 230 or 460 volts. This one is the more hazardous of the 2. It typically happens if you touch a live lead inside the welding equipment, while the power is on, and you're simultaneously touching the equipment case or maybe some other earthed metal.
Right.
It's why the use of residual current devices, RCDs, is just crucial.
RCDs, yeah.
Yeah, think of an RCD as like a super smart circuit breaker. It's designed to detect even tiny electrical leakages and trip instantly, cutting the power before serious harm occurs.
Got it. So that's the high voltage internal risk. What's the other one?
Then there's secondary voltage shock. This is typically lower, maybe 60 to 90 volts. Now, while it's lower voltage, it can still be serious, especially if you've got wet hands or you're sweating, that kind of thing.
Oh, conductivity.
Exactly. This happens when you touch a part of the electrode circuit, maybe a damaged table, for instance, and you simultaneously touch both sides of the welding circuit, so like the electrode and the workpiece or the welding earth. That's why low voltage safety devices are also vital here.
So it's not just the big, obvious current, but these subtler paths to danger, too. How do you even set up a safe welding circuit, then, to prevent these kinds of shocks? It sounds like it needs to be pretty foolproof.
It absolutely needs to be robust. A correctly wired circuit, as our source specifies, really requires 3 distinct leads. It creates this complete triple secured loop.
Okay, 3 leads.
Yep. First, you have the welding lead. That delivers the current from one power source terminal straight to your electrode holder or your torch. Then there's the welding return lead. That completes that primary circuit, bringing the current back from the workpiece to the power source.
Okay, that makes sense. Lead and return. What's the third?
And finally, critically, a separate earth lead. This acts as your safety net. It connects the workpiece directly to an earth point, making sure any stray current has a safe path to ground. And the power source itself also has to be earthed.
Right.
And all 3 of these leads, they must be robust enough to carry the highest welding current you're planning to use for the job.
Okay, that structure makes sense. Now, here's something that jumped out at me, something called duty cycle. It sounds technical, but the source says it's absolutely critical for preventing electric shock. My gut reaction might be, just run the machine as long as possible, but that's clearly not right, is it?
No, you've hit on a really common misconception. That run it till it drops mentality is exactly what duty cycle is designed to prevent. It's essentially the equipment's built-in rest period, how long it can operate at a certain power level before it absolutely needs to cool down.
Okay. Like interval training for machines.
Exactly like that. It's a key indicator of your equipment's endurance, and it directly relates to preventing overheating, instability, and yes, electric shock risk. It's expressed as a ratio. Duty cycle, welding time, total time by 100.
Right.
And it's typically based on a 10-minute total cycle time. So, for example, a power source rated at 350 amps at a 60% duty cycle means it can safely deliver 350 amps for 6 minutes out of every 10. Then it needs 4 minutes to cool.
I see.
Pushing it past that point isn't just inefficient, it's actively dangerous. You risk damaging the equipment and creating a shock hazard.
Okay, that's a really clear explanation. Duty cycle isn't just about efficiency. It's fundamentally about safety. So we've established that electric current and the heat it generates pose immediate threats. But welding also creates this incredibly intense light. And when you look closely at that brilliant arc, well, maybe don't look closely. It's far more dangerous than just being bright, isn't it?
Absolutely. That intense glow is actually a complex spectrum of radiation, far beyond what you can see. It includes invisible infrared, which, yeah, brings the heat. And then more insidiously, ultraviolet radiation, or UV. UV can do damage you won't even feel until hours later.
Hours later. Wow.
Yeah. The welding arc emits light across three main ranges. Infrared, that's wavelengths greater than 700 nanometers, felt as heat. Visible light, that's 400 to 700 nanometers, the part we actually see. And then ultraviolet radiation, UV, with wavelengths less than 400 nanometers. And UV radiation is particularly insidious. All arc processes generate it. Excess exposure can cause skin inflammation, potentially skin cancer over time, or permanent eye damage. The most common risk among welders and inspectors is probably arc eye, or sometimes called flash.
Arc eye. I mean, just the name sounds incredibly painful. What is it exactly, and what does it actually feel like?
It is painful. It's caused by that UV radiation damaging the outermost protective cell layer of the cornea, the front of your eye. As these damaged cells die off, they expose the highly sensitive nerves underneath, and these nerves then rub against the rough inner surface of your eyelid.
Ouch.
Yeah. It leads to intense pain, often describes feeling like sand in the eye, and it gets much worse in bright light. But what's really crucial to remember, as I mentioned, is that arc eye often develops hours after the exposure.
So you wouldn't even know it happened right away.
Exactly. You might finish a shift, feel perfectly fine, go home, and then wake up in the middle of the night feeling like someone's poured sand directly into your eyes.
That's truly insidious, like a delayed onset agony.
Mm-hmm.
So it's not just immediate pain, but a real sneak attack. What's the fastest way to get relief if, heaven forbid, that happens?
Precisely. The good news is, while it's excruciating, it's almost always temporary. The pain usually lasts about 12 to 24 hours, though it can be longer in really severe cases. Resting in a dark room definitely helps soothe it, and a qualified medical professional can provide anesthetic eye drops for pretty quick relief.
Okay.
But obviously, prevention is key. Like always wearing those safety glasses with side shields significantly reduces the risk. It's such a simple thing.
Absolutely. Prevention beats cure every time.
And that UV doesn't just hit your eyes, it'll affect your skin too. It causes reddening and irritation. And no, it won't give you a nice tan like a sunburn from the beach. This is different. In really bad cases, you can actually get severe burns and blisters with the skin flaking off later. And prolonged or frequent exposure over years, that can even lead to skin cancers. So cover up.
Okay, so UV is bad for eyes and skin. What about the other types of light?
Well, visible light, especially the intense blue wavelengths near the UV spectrum, can be dazzling. In extreme cases, it could potentially damage the retina's sensitive nerves, but usually that's not a long-term effect. Depends on the intensity and how long you're exposed. In infrared radiation, the heat you feel, that can lead to gradual irreversible lens opacity, basically cataracts with prolonged exposure over many years. Though with normal welding arcs, that usually only happens if you're very close. Thankfully, our natural reaction is to move away from intense heat, which helps mitigate that risk somewhat.
Right, your body tells you to back off. Okay, so shifting from the visible threats of heat and light, let's talk about the invisible but equally dangerous hazards. Fumes and gases. These sound surprisingly complex, often containing like a whole cocktail of chemicals depending on exactly what you're welding.
Indeed. The composition of welding fumes varies massively. It depends on the process you're using, the electrode type, the base metal, any coatings on the metal. Lots of factors. Generally, the acute short-term effects of fume exposure are temporary. Things like burning eyes and skin, maybe dizziness, nausea, even a fever sometimes. Zinc fumes, for example, from welding galvanized steel can cause something called metal fume fever. It feels like a bad flu, but it's temporary.
Okay, temporary effects. But there's one specific substance mentioned in our source material that, when I first read about it, truly made my jaw drop. The danger seemed almost unbelievably extreme.
You're almost certainly referring to cadmium.
Yes.
Yeah. It's truly a nightmare scenario in welding safety. Cadmium is a highly toxic metal. You might find it as a coating on some types of steel or maybe in certain silver solders or brazing alloys. And cadmium fumes. They can be fatal even after quite brief exposure. The initial symptoms might seem similar to metal fume fever, but they are not to be confused. This is far, far more serious.
Yes. I mean, the source literally states 20 minutes of welding in the presence of cadmium can be enough to cause fatalities, with symptoms appearing within an hour and death potentially occurring 5 days later. That's just an unbelievably stark, terrifying detail. Why is cadmium specifically so uniquely lethal compared to other fumes? What makes it different?
It's because cadmium, when inhaled, attacks your lungs and kidneys directly, rapidly, and severely. Unlike other fumes that might cause irritation or a temporary illness like metal fume fever, cadmium interferes directly with critical bodily functions. It can lead to widespread organ failure.
Wow.
It doesn't just make you sick, it's almost like it's designed to shut down your body's essential systems. And crucially, by the time you feel severe symptoms, the damage can often be irreversible. That's why it's so incredibly critical to identify materials before you start welding. Know what you're working with.
Absolutely critical. Okay, what about the gases involved?
Right, so gases are another invisible threat. Most shielding gases used in welding, things like argon, helium, carbon dioxide, they are non-toxic in themselves, but the danger is that they displace oxygen in the air you breathe, especially in confined spaces.
Asphyxiation risk.
Precisely. This can quickly lead to dizziness, unconsciousness, and ultimately death if the brain is deprived of oxygen. And beyond the shielding gases, you have other potential gas hazards. Some degreasing compounds like trichloroethylene and perchloroethylene if they're near the welding arc. The heat and the UV radiation can decompose them into highly toxic gases like phosgene. Extremely dangerous.
Phosgene, wow.
Yeah. And even just the UV radiation from the arc hitting the surrounding air can create harmful gases like ozone and various nitrogen oxides. These can cause headaches, chest pains, and irritation of the eyes, nose, and throat.
So with all these invisible dangers swirling around, fumes, toxic gases, oxygen displacement, what does this all mean for someone trying to stay safe? Beyond just, wearing a mask, what are the really actionable takeaways here?
Well, the most obvious rule, yet one that's surprisingly commonly violated, is simply to keep your head out of the fume plume.
Seems simple enough.
It does, but you'd be surprised. That plume rising directly from the arc is where the concentration of fumes and gases is highest. So position yourself to avoid breathing it directly. Beyond that personal positioning, engineering controls are key. Good mechanical ventilation is essential. Ideally, you want local exhaust ventilation, or LEV, right at the arc itself to capture fumes at the source. Fixed or movable exhaust hoods can also work.
And if those aren't enough?
If ventilation controls aren't sufficient to clear the air, then an approved respiratory protective device, a respirator, becomes absolutely necessary. A good rule of thumb is, if the air in the welding area is visibly clear and you feel comfortable breathing, the ventilation is likely adequate. If you see haze or smell fumes, it's probably not.
Okay, that makes sense. How do you identify specific hazards like that cadmium?
Right, identification is paramount. Always read the material safety data sheet, the MSDS, or nowadays sometimes called the SDS safety data sheet, for the consumable, the electrode, or wire you're using.
Okay.
Think of it like the ingredients list and warning label combined. It details the hazards and the necessary precautions. Also, you need to be aware of the occupational exposure limit, or OEL. In the UK, this is defined in the COA-SHH regulations, the control of substances hazardous to health. The OEL specifies the maximum safe concentration of airborne substances averaged over a period. You need to stay below that limit.
Got it. MSDS and OELs.
And crucially, always know your base metal. What is it made of? And just as important, are there any coatings on it? Paint, plating, galvanizing. These can all produce toxic fumes when heated.
Like the cadmium example.
Exactly. And special attention, absolutely critical attention, is needed when welding in confined spaces. This requires a formal risk assessment, often a permit to work system, and definitely gas testing before and during the work because of those extreme dangers of asphyxiation and the rapid buildup of toxic fumes.
Right. Confined spaces multiply all those risks. Okay, finally, let's talk about noise. It might seem maybe less dramatic than electric shock or toxic fumes, but its effects can be just as serious and permanent over time. And often, people might think it's the welding arc itself that's the biggest noise culprit. But our source suggests maybe that's not always the case, right?
Exactly. You're right. While the arc itself can certainly contribute to the overall noise level, it's often not the primary driver of long-term hearing damage in general day-to-day welding operations. The real culprits, the things that generate consistently high noise levels, are usually the ancillary operations.
Ancillary operations, like what?
Things like the relentless chipping of slag off the weld, the high-pitched whine of grinding weld smooth, the percussive hammering that often seems to echo through the entire workshop. Those are the activities that create the consistent cumulative noise exposures that can silently erode your hearing over time.
Silently erode. That's a good way to put it. Because hearing loss is often gradual.
It is. And long-term exposure to loud noise doesn't just damage hearing permanently. It can also increase stress levels, elevate blood pressure. It contributes to tiredness, nervousness, and general irritability too. It affects your whole well-being.
So there's a threshold for action.
Yes. The threshold where mandatory hearing protection is required is generally when noise exposure averages greater than 85 decibels over a standard 8-hour working day. And if you're exposed above that level, annual hearing tests are typically required as well.
And typical welding doesn't usually hit that.
Normal welding operations, most common processes, generally don't reach those sustained levels on their own. But there are two key exceptions mentioned. Plasma arc welding and especially air carbon arc cutting or gouging, those can be extremely loud.
Oh, okay.
For those specific processes, hearing protectors are an absolute must. But more commonly, as I said, the hazardous noise associated with a welding job comes from those ancillary tasks, the chipping, grinding, hammering. So hearing protection is also a must when you're performing those tasks, or even just working nearby while someone else is doing them.
Right, it's the whole environment, not just the arc itself. Okay, wow, we've covered a lot of ground today. From the immediate danger of electric shock and those surprising details about duty cycle, to the insidious, delayed effects of light radiation like arc eye, and the truly deadly potential of something like cadmium fumes, plus the noise.
Yeah, it's quite a range of hazards. And if we try and connect this to the bigger picture, it really just underscores the absolute importance of having a proactive, a holistic approach to safety, not just reacting to incidents. The best way to manage all these risks is through comprehensive risk management programs. It's a structured process. Well, it involves systematically identifying all the potential hazards first, then assessing the level of risk they actually pose in your specific situation, and then critically implementing suitable control measures to reduce those risks down to an acceptable level.
That sounds great on paper, a comprehensive program. But thinking about the real world, how often do these programs actually translate into daily practice effectively on the shop floor? What's the biggest hurdle, do you think, to truly implementing them consistently?
That's an excellent and very practical question. I think the biggest hurdle is often complacency and maybe a lack of continuous vigilance. People get comfortable with routines, or they're under pressure to get the job done quickly, or sometimes they simply forget or underestimate the risks.
It won't happen to me syndrome.
Exactly. That's precisely why evaluation and review are such essential parts of the process. It's not a one-and-done thing. You absolutely must ensure that the control measures you've put in place have actually worked, that they've eliminated or significantly reduced the risks. And you need to regularly check that the entire safety process is functioning effectively. That includes identifying any new hazards that might crop up and managing those ongoing risks. It has to be a continuous cycle of active engagement and improvement, not just a dusty manual on a shelf or a checkbox exercise.
A continuous cycle. That makes sense. It's not static. So what does this all mean for you listening? Beyond just understanding the specific dangers like shock or fumes, this deep dive really shows how crucial constant awareness and preparedness are, not just in welding, but really in any industrial setting. It's a powerful reminder that safety isn't just a list of rules you memorize. It's a constant, active engagement with your environment and recognizing its potential threats, visible and invisible. What stands out to you most from this deep dive into arc welding safety? Perhaps is that description of the delayed agony of arc eye, or the truly shocking facts about cadmium poisoning, or maybe the simple but critical math behind understanding a duty cycle. Whatever it is, we hope you feel much more informed now and better equipped to spot and prevent these risks, not just for yourself, but importantly for everyone working around you too. Until next time on The Deep Dive, stay curious and above all, stay safe.